Let's solve the differential equation. dy over dx is equal to negative xy squared plus 3 plus x plus 3y squared all over x squared times y cubed plus 6xy cubed minus 12y cubed. And the initial condition, we have y of 2 is equal to 0. Okay, first let's factor this out. For the top, for the numerator rather, we have a 3 plus x over here. And then if we look at xy squared and 3y squared, they both have a factor of y squared. And if you factor that out, you get x plus 3. So that's just going to be like this. Now the denominator, they all have a factor of y cubed. So I'm going to factor that out. So we'll have y cubed times quantity x squared plus 6x minus 12. Now I can factor out an x plus 3 from the top, and I'm going to be left with y squared plus 1. And the bottom, I'm just going to leave it alone. Okay. Now I'm going to bring all the y's on the left, all the x's to the right. So y cubed and y squared plus 1 go to the left. And then we'll leave the x's on the right. So we'll have to move the dx to the right. Now we have to integrate. So for the left here, I'm going to rewrite this. I have y cubed over y squared plus 1. So think of it like this. What is y cubed divided by y squared? That's equal to y. So if I take y times y squared plus 1, that's y cubed plus y. But notice I don't have a y here. So for example, if I had y cubed plus y over y squared plus 1, that's going to equal y. So I would like to have a y here, which means I have to add 1 and then remove 1. So really what this will be is y cubed plus y over y squared plus 1 minus y over y squared plus 1. And on the right here, we're going to use a u substitution. We'll let u be the denominator. So du will be 2x plus 6. So this will be, here we have x plus 3 dx. Here's 2 times x plus 3 dx. So then that'll be du over 2. So we'll have a 1/2 here. Negative du over u. And this simplifies to y minus y over y squared plus 1. And this will be negative 1/2 ln of u plus c. And I can break this up into two separate integrals. Now u, we said, was x squared plus 6x minus 12. The antiderivative of y is y squared over 2. This one we can use u substitution. So we'll let u equal y squared plus 1. Du will be 2y dy, so this will be 1/2, again, du over u. So we negative 1/2 ln of u. And now we can replace the u to be y squared plus 1. we have to use the condition that they gave us at the top, namely that y of 2 is equal to 0. So y is going to be set to 0. So 0 squared over 2 is 0. ln of 0 squared plus 1, that's ln of 1, that's also 0. Okay, now we can plug in x equals 2. So we have 2 squared is 4, minus 12 is negative 8. 6 times 2 is 12. So add those up, you get 4. So c is 1/2 ln of 4. So in total, plug that in, y squared minus 1/2 ln y squared plus 1 is equal to negative 1/2 ln x squared plus 6x minus 12 plus 1/2 ln of 4. Simplify this. Multiply both sides by 2. We have negative ln x squared plus 6x minus 12 plus ln of 4. I can really think of this as ln of 4 minus ln x squared plus 6x minus 12. And now I can divide. It's 4 over x squared plus 6x minus 12. And on the left will be y squared minus ln absolute value y squared plus 1. Now we can also add the ln of y squared plus 1 to both sides. And so what happens here is you have to add the two natural logs, which means you have to multiply. So the y squared plus 1, so think of this as y squared plus 1 over 1. Y squared plus 1 has to multiply the 4 to get 4y squared plus 1, and we'll just leave the denominator like this. And this should be our final answer.